Hello everyone, so welcome to my playlist on single variable calculus. Today we are going to see the concept of increasing function and decreasing function and hence the concept of monotonic functions. We will try to see the definition with the help of graph of a function. So we will try to understand the definition first. Then we will see what is the connection of increasing decreasing function with its derivative. Okay, so how derivatives and monotonic functions are connected. And at the end we will see 2-3 examples for your understanding purpose and couple of examples for your homework. Okay, so let us start with the concept of increasing and decreasing function. Okay, so suppose if you have a graph of a function. Okay, so you have some graph of a function. Now question is, when you say a function is an increasing function, so what you do is, along the x-axis we will fix the orientation. You always go from left to right. Okay, so when you go, your x goes from left to right, you see the graph of the function. Okay, if the graph of the function goes up, then we say that the function is an increasing function. Okay, and suppose if the graph of a function goes down, then we say that the function is a decreasing function. Okay, so again here you can see the graph is going up, so therefore the function is an increasing function. So like if I give a name, suppose if I call this as A, B, C and D. So as you can see, from A to B the graph is going up, therefore the function is an increasing function. From B to C graph is going down, therefore the function is a decreasing function. And here in this interval the function is again an increasing function. Okay, so once you know the graph, you can easily tell whether the function is an increasing or a decreasing function. But if you do not know the graph of the function, then how will you tell whether the function is an increasing or a decreasing function? So for that, obviously one should have a definition. So let's see the definition of an increasing function first. Well, instead of giving you the definition directly, let's try to arrive at the definition. Okay, so now here if you observe, here you can see that your function is what? It's an increasing function. Now what is happening? See, if you take any x1 and x2 in this interval, you take any two numbers where x1 is what? Less than x2, because x1 is on the left of x2. What is happening? The function is increasing. That means what? If this is my image of x1 and this is my image of x2, then what can you say the relation between the images? Your f of x1 is less than f of x2, right? So your graph is increasing. So if x1 is less than x2, their images should also follow the same inequality, then only the graph will increase, right? So if x1 is less than x2, you see their images. So for an increasing function, their images should also follow the same inequality, then only your function will be increasing. You take any, suppose if I call this as x3 and this as x4. So for x3 and x4 also you can see this is my f of x3 and this is my f of x4. So f of x3 is less than f of x4. So if this is true for all elements in the interval, then we say that function is an increasing function in that interval. Okay, so if I want to write down to be precisely, so if x1 is less than x2, then you take their images. So if their images also preserve the same inequality, okay, so when you take their images, inequality remains the same, then we say, and this is true for all x1, x2 belongs to some interval, then we say that your f is an increasing function over that interval. Okay, so this is what the definition you usually see, and then student gets confused that why this is the definition. The answer is this. You see x1 less than x2, you take their images. As graph is going up, your images should also follow the same inequality. So if such a thing happens, we say that the function is an increasing function. And what about decreasing? So as you can see, if you take any x1 and x2, obviously your x1 is less than x2 because x1 is on the left of x2. You take the images. So from here, let me erase this. So from here you can see that this is my f of x2 and from here you can see this is your f of x1. So which is bigger? F of x1 is bigger, right? So if you have x1 less than x2 and the graph is decreasing, so obviously image of x1 should be at the top and image of x2 should be at the down, then only the graph will decrease. Okay, so if your x1 is less than x2, but when you take their images f of x1 and f of x2, the inequality reverses. F of x1 is greater than f of x2. So when the inequality reverses, and if this is true for all x1 x2 belongs to I, then we say that your function is a decreasing function. Okay, so if it is increasing function, that means what? If x1 is less than x2, you take their images, your f of x1 is also less than f of x2. And for decreasing function, if x1 is less than x2, you take their images, then the inequality reverses. Then we say that the function is a decreasing function. Okay, and that's how these two definition comes into picture, by visualizing the graph. So now I hope you will not get confused by directly looking at this definition. Okay, it is arriving because of this thing. Okay, now there are some more, some author divide this into two parts, like increasing and strictly increasing. What some people do, if x1 is less than x2 and images is less equal, then we say that, or here also people write equal to, then people say that this is an increasing function and the decreasing function. And if you have strict inequality, then people say that function is strictly increasing and the strictly decreasing function. Okay, so some author do this bifurcation, but okay, since I am referring Thomas' book and he is not doing this bifurcation, so we will only stick to one definition, that if x1 is less than x2, then f of x1 less than f of x2, then function is increasing, and for this we will say that the function is a decreasing function. Okay, so we will not go into strictness. Okay, so there's the notion of increasing and decreasing, and now the question is, when do you say a function is a monotonic function? Monotonic function. So once you see, okay, so let me again draw the graph so that will be easy for you to understand. So over an interval, suppose this is my interval I, over the interval, if function is increasing only, then we say the function is a monotonic function. Or if the function is only decreasing, then we say the function is a monotonic function. So if a function is either increasing or only decreasing, then we say it is a monotonic. That means it is going in the same tone. So either it is completely increasing or it is completely decreasing. Okay, so if someone says consider a monotonic function over an interval I, that means what? He is saying that over that interval your function is either increasing or your function is either decreasing. So that's what you mean by a monotonic function. Okay, now we know the definition. So if you know the graph, you can easily tell the increasing and decreasing nature of a function. If you don't know the graph, then we have a definition, this definition and the one which I wrote here. But see, again, this is not possible to do every time. See, as soon as I say an interval, there are infinitely many points in that interval. You can't keep on taking each and every point. It's a very lengthy process, right? So even though we have a definition, but it is very difficult to check for every point. So question is, how do we do this task? So given a function, if I want to see increasing or decreasing, then how do we do that? One way is by definition, but if I don't want to go by the definition, it's very tedious process. Then who will help you? Now comes derivatives in the picture. Derivative will help you to check whether the function is increasing or a decreasing function. And for that you have a very nice theorem. I'm not going to take a proof you can find in any of the standard books, but you can simply Google also, not an issue. So the theorem says, if you have a function, so your function is an increasing function if and only if your derivative is positive. So I'm assuming that my function is a continuous function and a differentiable function. Okay, I'm assuming that. If your function is not differentiable, then you cannot talk about this. Okay, so if the function is increasing, if and is same as to say that the derivative is positive. So many times, okay, and second one is your function is a decreasing function if and only if its derivative is negative. Okay, so many times when you study differentiability, people directly uses this as a definition. let f be a function, we say f is an increasing function if derivative is positive, and we say function is a decreasing function if the derivative is negative. This is not the definition. The definition is the one which I told you over here and here. This is true for any function, whereas this is true only for differentiable functions. Okay, so when you have differentiable functions, you can take this as a definition, but once again I am saying this is not the definition. This is the nice condition we have when you have a differentiable function. Okay, so that's what the connection is. Now let us see some examples so that this theorem will be clear to you. So suppose this is an example and you have to tell me whether the function is an increasing or a decreasing function. Okay, I should tell you interval also. You take the interval as a complete real number system. So this is an interval you have and you have to tell whether this is increasing or decreasing. So obviously you can't keep on checking for each and every point over the interval because it's infinite. There are infinitely many real numbers. So that definition goes away. You can't use that definition. Do I know the graph? I don't know the graph of this function. So I can't say whether it's increasing or decreasing by looking at the graph. So, but I can say that this is a polynomial. So good, is differentiable function. So I will use the theorem. So for that I will first find the derivative of the function. So what is the derivative? 9 into x minus 7 raised to 8. Now what can you say about the derivative? Is it positive or negative for x belongs to this thing? Now as you can see, your 9 is a positive number. X minus 7 can be anything positive or negative, but I am taking its even power. So therefore this is also greater than 0. So therefore your derivative is always greater than 0. At 7 it is equal to 0, but it's okay. So the derivative is what? Is always positive. That means what? Your function is an increasing function over real numbers. Okay, so let me try to show you the graph of this using GeoGebra. So you go to Google, type GeoGebra, and you go to the website. As I told you in the first lecture on how to plot the graph, you click on the square, you click on the graphing calculator, and then you can type the function over here. If you have missed that, then you can see the lecture number 1 where I have told about how to use GeoGebra to plot the graph. So here if you see x minus 7 raised to 9, and as you can see that it's increasing function. As you go from left to right along x-axis, it's always going upwards. Graph is always going upwards. Graph is never coming down. Okay, so since it's always going upwards, therefore the graph is an increasing function, and that's what we saw. The derivative is positive over whole real number. So over whole real numbers it's increasing function. Okay, and one more thing here is showing that it's touching the x-axis, but that's not the scenario. Okay, it's very close to x-axis because we know that what are the roots of this polynomial? 7 is the only root, but 7 is repeating 9 times. So what is the algebraic multiplicity? Algebraic multiplicity is 9 for the root 7 because it is repeating 9 times, and that's why you can see this very close to x-axis over here. So yeah, but it is only touching 7 on x-axis. Okay, so that was just a clarification. So yeah, so from GeoGebra you can see that the graph is completely increasing. Okay, now let's go for the next example. Okay, so now in this example I don't know the function, I don't know the graph of the function, but what I know is I know the derivative of a function. So if I know the derivative of a function, can we also tell the nature of the function, whether it is increasing or the decreasing? Okay, so answer is yes. So I need to see where is the function derivative is positive and where it is negative. So I need to see for which x my derivative is positive and for which x I want to see the derivative is negative. Now when this product is positive, when x is greater than 0 and x minus 2 greater than 0, or x is less than 0 and x minus 2 is less than 0. Because product of 2 negative is positive, product of 2 positive is positive. Okay, and when this thing will happen, so either one is positive and one is negative, or this one is negative and this is positive, right? Okay, now let's go for this case. X greater than 0 and this will imply what? X is greater than 2. So for which x you will have this condition? So obviously when my x is in the interval 2 comma infinity, because greater than 0 and greater than 2, so obviously it has to be greater than 2. It's AND over here. What about this thing? X minus 2 less than 0 means x is less than 2. So x is less than 0 and x is less than 2. So this will tell me that my x should be in the interval minus infinity comma 2. I hope I am doing correctly. Yeah, so sorry. So it should be less than 0 and less than 2. So this should be minus infinity to 0. So whenever your x is in this interval, my derivative is always positive. That means what? Your function is increasing, not derivative, okay? Your function is increasing. What about this? X minus 2 less than 0 means x is less than 2. So x greater than 0 and x less than 2. That means I have 0 comma 2. X less than 0 and x greater than 2. Is this case possible? X should be negative and x should be greater than 2. So this case is not possible. So only in this interval the derivative is negative. Okay, so therefore the final answer, if the question is where it is increasing and where it is decreasing, so your function is increasing in the interval minus infinity 0 union 2 to infinity. In this interval your function is an increasing function, and in the interval 0 comma 2 your function is a decreasing function. So even when you know the derivative, you can use this theorem to say about the nature of the function, about the increasing or the decreasing nature of a function. Okay, so I hope this is also clear. Now let me give you a couple of homework problems, and your job is you have to comment the answer in the comment section. So here are the two homework problems for you. You have to tell me over which interval the function is increasing and decreasing, and same for this function. Okay, so you can use this derivative theorem to answer the question about the increasing and decreasing, and later on you can also use, if you wish, you can use GeoGebra to verify your answers. So I hope this concept of increasing and decreasing is clear. If you have any doubt, you can ask me in the comment section, and if you don't have any doubt, then do not forget to like, share and subscribe. Thank you.